Hi everyone, this is Derek again, and I'm in this video series. It's a continuing video series from creating pattern recognition from marketing data. And for this video series, I'm going to teach you how to do attribute combination analysis using a technique called conjoint analysis. Now, the previous videos before this, I dealt with the issue of creating segmentation, targeting, and positioning using segmentation clustering. Targeting, I used the decision tree, and positioning, I taught you how to use multidimensional scaling. So this is just a follow-up to that, where we have now a combination of attributes and we want to put them together. Now, you must be wondering why I've got very cute little animation right here. So if you see this is actually a rhino launcher. This is actually a cattle snake, and this is a dogfish. So for those of you who know what this means, is actually putting attributes together that don't mean a thing, but hey, people like it. Anyway, now before I move on to the technical stuff, let me just give you some theory or background of what conjoint analysis does. Now, conjoint analysis is basically, as what is stated here, quite useful in market research because it helps people to understand what people value in terms of different attributes like features, functions, and benefits, or maybe like color, price, or design that make up an individual product or a service. So what you want to do is you want to position your product or service in terms of its relevant relative importance of their salient attributes of a product or service that will target to a specific segment based on their preference. Yeah. It's the combination of these attribute levels, like for example, if you're talking about color, you may have black, you may have white, you may have pink, and you ask the respondents to evaluate each of these attributes and their levels based on their desirability and also the combination of these attributes together. So the result would be the utilities that's attached to the combinations that you have, as well as which attribute is the most desired attribute, and also the level that is the most desired within each of these attributes provided by the respondents. So it's quite everything all in together, conjoint analysis. So conjoint analysis helps you with positioning your product and your service, because the purpose is to find out which characteristics is the most important, which level of the characteristics is most preferred, and of course, which combination of these levels of attributes is the most preferred one. Because every single attribute and every single level of the attribute is just one part of the product or service that you're offering. So what you're going to do is that you're trying to infer the relative importance of the parts and put them together as a combination of attributes so that the customer can tell you which combination they prefer as a whole, and that will give you a clear indication of what to package in. So for example, if I would give you one, let's say you want to do menu, right? Menu A, menu B, menu C, but you don't know what kind of attributes or what kind of products you want to put together in the menu. So that's one way of finding out using conjoint analysis. So let me give you another example here. Imagine you're selling television and you don't know which television you want to sell. Do you want to sell a Sony, which is priced at $2,500, 50-inch LCD? Do you want to sell a 42-inch plasma LG TV that's priced at $800, or a Panasonic 42-inch LCD TV that is priced at almost $2,000? It is the combination of these that you're asking your consumers to decide and see which one they prefer. Now, before I get into the technicalities, we do have to understand a little bit about what are some of the terms associated with conjoint analysis. Now, this is very important so that you understand what's going on behind the scene. Pathword functions. Pathword functions, or what we call as utility functions, describes the utility the consumers attach to each of the level of attributes. So for example, if let's say I have color, pink, black, and white, which one do I like best out of pink, black, and white. I might like black. I don't like white so much. I detest pink. So I will know based on the utility functions. Next is relative important weights. Relative important weights are placed on attributes themselves: color, design, price. So I get to find out which one I place more important. Do I place more importance on color or price or even on the design? Then there's the attribute levels. So back to the color example, my levels of my color will be white, black, pink. These are the values assumed by the attributes. Full profiles are the combinations of the values of the attributes, putting together the attributes together, and it comes out as a specified design. So which of the specified design do a combination of the attributes that equates to the specified design that the consumers prefer the most. And finally, orthogonal arrays are special class of fractional designs that enable the efficient estimation of these all main effects. Now what this means is, if you have 3 attributes with 3 levels, each attributes, 3 to the power 3, my maths don't fail me, that means you need 27 combinations, right? Yeah, right. But orthogonal arrays helps you to make these less. Now, how do they do it? There is a function behind it that finds the most efficient estimation of these main effects. So just trust SPSS on this one when they create the main effects for you. Now, if you are not satisfied with the orthogonal designs that they come up with, you can always do it again and again and again, because they always come up with different orthogonal designs anyway. But it's always best to have a couple so that you decide what best works for you. So I'm going to go now to show you how to do conjoint analysis. Now, conjoint analysis, there are basically 5 steps. First, you have to identify what's the problem. Attributes and levels. What are the attributes? What are the levels associated to those attributes? Then you have to design the orthogonal design, which is to lower down the number of combinations. Like I said, if you have 3 attributes with 3 level of attributes each, then you will have 3 to the power 3, that's 27. But maybe for this example, you might see less. Try not to be too much because it gets a bit complicated later on. Get the respondents then to rate the preference of combinations from the orthogonal design, which I'm going to show you how to get it. Select the conjoint analysis procedure, which for this one we have to use the SPSS syntax, and then finally interpret the results by showing at least some graphs of utility as well as pathword functions. Okay, so I'm going to give you this example from a sneaker. Formulate the problem. So first off, what are my attributes and what are my attribute levels? Second, make sure that these attributes are salient in influencing consumer preference, actionable, which means they can be done. Don't come up with something like you want black, you want white, and then you want metallic, but then you have no way of putting metallic in your color. It's always good to have at least 3 levels, unless the attribute is naturally occurring in a binary form, yeah, like black and white. And then take into account the attribute levels prevalent in the marketplace. Sometimes don't put in an attribute value that people generally find odd or don't like. Now that's going to complicate a lot of things. So try and do your market research to see what are the generally accepted colors or generally accepted price or even the design or whatever attributes that you have in terms of the levels. Yeah, so think about it. Think about how iPhone does it. Yeah, iPhone does really good things, especially when it comes to conjoint analysis. But it all comes back to the objective study. Okay, so let's begin. Sneakers. So I've got 3 attributes here with 3 numbers, 3 description each, and of course the price. Now, you notice that for price, you have $90, yeah? However, don't let this fool you, because you may think that people might go for the lower price. But if you can see in conjoint analysis, it may not be the case. So I'm just going to show you and simulate this in SPSS while I close up my face, and then you see the SPSS screen, and then you know what I mean. Okay, so you start off with a blank SPSS data file. Then you have to create now your orthogonal design. And to do this, you go to Data, Orthogonal Design, Generate. Oh, sorry, I forgot to take this out. I'll reset it. Now, from this sneaker attributes, let me just show you again this one here. Now we're going to create the orthogonal design based on this. And what we're going to do is we're going to start off with the first one. So now the factor label can be any name. It can be a longer name if you want to, but I just want to keep it easy. But it's up to you. Sometimes the factor name may be a short one and the factor label may be a long one. Next will be the upper part of the shoe. And finally will be the price of the shoe. Now, what I'm going to do is I've got to define the values of each of the attributes. So each has three attributes, three values. So let me start with the sole, define the values. I have 3 here, fill it in. Of course, I start with the first one, plastic. The second one is polyurethane. Thank God I didn't go to science when I was younger. I would not be able to pronounce all this. And finally will be rubber. Rubber. Yeah, and continue. Next will be upper, define the values. Again, there's 3 attributes. I'll fill it in. I'm gonna call this nylon. There is the canvas, and finally there is the leather shoes, and of course price. 3 attributes here, fill it in. I have firstly $90, second will be $60, and thirdly will be $30. Cool. So now I've got all my attributes and my levels in my attributes. I'm going to put this into a new orthogonal file, which I'm going to save in here. Yeah. So find your own file path. Now it's very important that you know your file path, because the file path later on will be used in your syntax file. So please remember where you saved it. It's always easier to save it onto the desktop, because then you will know where to retrieve it later on. But I'm just going to find my own file path and just put it here. So here, because I've got already a shoe orthogonal, I'm just going to call it, well, actually I can call it shoe orthogonal and just save right here. Yeah, replace it. And I'm gonna press OK. Replace. Done. So now what I want to do is I want to see what is the cards that has been produced, right? That means the combination that has been produced. So what I got to do is I got to obviously open up my shoe orthogonal dataset. Now this is my shoe orthogonal dataset, which has created 9 cards for me. Now if you remember, I said just now that they will create not 27 3 to the power 3, but they will do a combination of the main effects. So if you feel that this orthogonal design is not enough for you, then you can create another one, which probably might give you another different set of orthogonal design. But for me at this stage, I think this will be just nice, and I will stick to this. Usually that's what I do. Remember, these are just data sets. Okay, so if I click on the label, I get to see what are the shoes. Now, of course, looking at this, how am I going to create what do you call this, a card design for my respondents to fill in, isn't it? It's quite difficult for me to see. So I usually use the orthogonal design display. You can take this data, orthogonal design display, put in the three variables, list for the experimenter. That means to let the experimenter see this format here, and for the subjects so that they can choose profile by profile. So if you press OK, this is what you get. Now this may be for the experimenter, which is obviously the researcher, and then each of this becomes a card. So you might probably want to mock up, you know, mock up a design of all these shoes. Yeah, 1, 2, 3, 4, 5 with all the different specifications in it, and then you can put the price on the specification. Now, what needs to be done is that all these 9 cards need to be evaluated by all your respondents, which means if I have 100 respondents, then every single one of those 100 respondents has to evaluate their preference of all 9 cards. Yeah, so let me just put it this way. If I have something like this, you see this? This is another data set based on the 9 cards that I had, or the 9 profiles, with 10 respondents. Now these 10 respondents has given me a Likert scale of 1 to 5 of their most preferred. Well, they just put in their number and their liking, and their least preferred in one of any of those cards. So for example, like respondent 1, they really like card 9. They really don't like card 1 and card 4, but they really like card 6 and card 9. So it's very seen here. So you've got to bring this card out and ask your respondents to rate every single card. So once you've got the rating of every single card with the 10 here, then you can now do the magic and do your conjoint analysis. So are you ready? Okay, let's do this. To do your conjoint analysis, sorry, I've skipped. This is number 2, which is create the orthogonal design, and then number 3 is to get your respondents to fill in the preference. And like I said, full profile approach to collecting conjoint data. Example of sneaker number, product number 9. Sole made of rubber, upper is made of canvas, and price is $60. Note here that prices are different for different combinations. Now here comes the interesting part. Conjoint plan. Running the conjoint analysis using the conjoint syntax. 3 things you need to note. If you remember, I asked you to remember where your files are. The orthogonal dataset, which you've created, the scoring dataset, which you have used from the orthogonal design to collect your dataset, and scoring from your respondents. Remember this one? Yeah, scoring. Now the scoring doesn't have to be limited to 1 to 5. It can be 1 to 100, it can be 1 to 9, as long as the scoring is quantitative for every single card. Then you have to have, so your orthogonal design, your scoring data set, and you got to know how many cards you're dealing with here. So you have 9 cards, so the first card label to the last card label. So in essence, for my example, it will look something like this. I've got my path, I've got my data set, the orthogonal design, and I've got my preference, which is the scoring data set, and finally card 1 to card 9. I've got 9 cards, right? What I can do is I can just copy this whole thing, but of course you got to make sure you always check your, actually I should put here remember to check your own path for your data. This is just an example only, okay? Right, so I'm going to copy. I'm going to go to my SPSS, open up the shoe preference data set, and then from here you can include in your syntax, or actually you can do it anywhere else. So I'm going to go to new file, new syntax. I'm going to paste my syntax, and as long as I don't get any red color here for my parts, I should be fine. Highlight this whole thing and then press run. Once you press run, you get this. This is your conjoint analysis output. Now, in this conjoint analysis output, you have the pathword utilities, and then the important values utility, and also the corresponding correlation. Now, these basically are the correlations between the observed and the estimated preferences, which are quite significant, which means that it creates the assumption, or it tells you that the combination of your preferences are actually reflecting what the consumers want. Now, of course, it would be easier for you to see this in form of graphs. So you can copy this utility, open up an Excel file, and then paste, and take each of the utility and insert in a 2D file. Yeah, a 2D file. And then you can, of course, put in some numbers inside if you want. Oh, let me just try this again. Let me see, insert. Yep, here we go. And you can see that for the sole, I have the pathword function. For the upper, I can do the same. Insert. I call this the upper. And here, just making some notes. Yeah, you go. And then finally for price. And this one, I have the pathwords. Now, what you need to do is to take this, and now you can see that each of the attributes has its own price. Each of the attributes, each of the utilities or the attributes has its own pathword utilities. So what this means is, for sole, your consumers prefer the plastic the most and don't like the polyurethane the least, okay, in terms of price. very interestingly, a lot of them actually like the $90, and for the upper, the most likable one is the canvas. So there you go. You now know the relative importance of each attribute, and then you can also add on, going back to the document here, just as a nice little filler, the relative attributes, important values. And of course, again, you get to see the same thing, which means that there you go, passwords. So important values. So now you have, in terms of attributes, price comes in first, next they see the sold, and upper is the least. In terms of each of the attributes, the most preferred one for upper will be canvas, for price will be $90, and for sold will be plastic. So this is actually a very good look on how you can see what is important to your customer's preference. Now, we're not done yet. I did mention that this is an attribute combination analysis, correct? So we do have to see what are the attribute combinations that is preferred by the consumers. Okay, so now if you want to see the attributes, okay, what you need to do is to look at the card important measurements. Now, this may look quite different. So here's what I'm going to show you how to do this. Take the means of your preference. Just take the means of your preference and then you get to see it. So how do you do that? You go to Analyze, you go to Compare Means, do Means. All you need to do is just put in all the cards in, right? And just press OK. Now you get to see, in terms of a report, that your consumers prefer, the highest one will be card 3, and that's the combination of the polyurethane, thin, canvas, and 90, and also polyurethane, polyurethane, nylon, and 60, but dislikes the most plastic, 2.9, and rubber. Okay, so this gives you a good deal of what they like. So if I were to go to my this outcome here, let's say I take this outcome, the most preferred combo here will be 3 and 5. If you can see 3, 5, 3.9, and the least preferred combo will be 4, 2.1. Okay, does that make sense? I hope so. Now, follow these steps. Now you know that you can create card 3 and card 5 as the most preferred two combos. Have a market research and test out these two combination of products. Lastly, before I leave you, I must tell you some of the assumptions and limitations of conjoint analysis. It may look simple, especially if you're doing things that you are looking for combinations, but there are certain limitations. So, firstly, conjoint analysis assumes that the important attributes of a product can be identified. In actual fact, most of the important attributes may not be fully realized unless you create different sets of orthogonal designs. And every time you do an orthogonal design, you will get a different set of design. So don't be freaked out if, let's say, you run 3, 4, 5 different orthogonal designs and every single time it's always different. It is going to be always different because remember, it goes through a randomized algorithm. Secondly, it assumes that the consumers evaluate the choice alternatives in terms of these attributes and then they make trade-offs, which means that they only evaluate what they see and they trade off the ones that they don't see. You might probably get an orthogonal design which really the consumers like, but again, this is pattern recognition and it is just a guesstimate and it is not a precise downright significance trial that we're looking at. It's just a guesstimate and a quick guesstimate of the attribute combinations. The trade-off model may not be a good representation of the choice process because again, like I said, there may be other alternatives that is not inside the choice process, and that's why it is becoming trade-off. Lastly, the data collection can be complex, particularly if you have a large number of attributes involved and also if the attributes have a large number of levels. And this model must be estimated at an individual level. The pathword functions are not unique, meaning to say that there are many other things that you might have to consider in your pathword functions. Like for example, if let's say the color the color attribute is probably affected by the design. So if you go back to our example, you notice that the polyurethane is the least preferred attribute in the sole or level in the sole. However, if you go back to our preference here, 3 and 5, polyurethane comes up at the top because it is the combination that creates the difference of the products. So you have to look at everything as a whole, yeah? And I guess doing conjoint analysis is really about taking the time to understand the theory, and that's why I created this video, because I know it's a lot of technical stuff that you need to know. But do remember one thing, that when you're doing the syntax, remember to put in the correct path of your file, or else you won't get the syntax running properly. Okay? So if you have any questions, please talk to me. This has been a very long video. I know, I'm sorry, but I thought I might as well just give everything to you so that it's easier for you to absorb and understand. So thank you very much, and I will see you soon with a new video, hopefully in the near future. Thank you and goodbye.